So try this matrix here. When you multiply this out,
How do we know it's gonna work? Because I'm a genius.
not really. The reason I know it's going to work is, see, what you're doing with these eigenvalues is you're swapping them. So they're distinct to begin with, but when you multiply them together, they become the same. So you want the diagonal entries to become the same, and then by putting the 1 up here, you give yourself a situation where there's, actually I shouldn't have circled those really. What I meant was, after you subtract the lambda off of the main diagonal, you're going to get 1 pivot, which means only 1 free variable. So it doesn't pull the eigenvalue doesn't pull its weight. So I prefer to do that. I think inverting a matrix would be just fine as well, but this saves you that trouble.
We would have to show that as a
Yeah, you just need to give it, it's very quick. Just say, okay, why is this not diagonalizable? Lambda is equal to 2 and 2, right? And if you even just told me the dimension of the eigenspace is 1, I would probably believe you just looking at it. It's such a simple little matrix.
Isn't that also a Jordan canonical form? So
It's a Jordan block, yeah, it's actually a Jordan.
So it can't be diagonal.
Well,
Well, this doesn't have a 0 up there.
yeah, but the fundamental reason that it doesn't work is because of this. And this is what I prefer to hear you say. Because that gets to the heart of what it means to be diagonalizable.
Is that true though? A matrix in a JCF form is not diagonal.
If I have a Jordan canonical form that is not a diagonal matrix, then it won't be diagonalizable. That is true. If you have 1s on a super diagonal anywhere, those won't go away. And those will create pivots, which will then not give you free variables. Yeah. Make sense? Okay, guys, you should be able to do the same thing with a plus b, a minus b, I don't know. Well, obviously a squared is a special case of this one. But just, I like these little problems because they force you to remember the little facts about distinct eigenvalues, gives you diagonalizable, repeated eigenvalues, you gotta look further, question a little bit more. It's just good stuff to be able to play with. So that's that. Just basically a matrix representation. I don't think I need to do it. I've done almost this whole sheet.
Which number is it?
The only ones on this sheet that I didn't do yet are number 3 and number 11. But I don't really think I need to do them. I feel pretty good. I did, and then I did a couple other problems that aren't on the sheet from 6.3 at the beginning of the
So it
review.
kind of made up for.
I mean, we've been at it a while. The trouble with, I mean, I'll keep going. I told you about my review sessions in my younger day, didn't I?
Yeah.
I started like this time of day, we'd go till like the middle of the night. We'd take multiple breaks, like coming back. That I don't necessarily think is a good idea tonight. I think you need to spend some time with your own thoughts and get a good night's rest as well. And listening to me say stuff and agreeing with it and saying, yeah, I follow that is not the same thing as you doing the problem. So you need to, and if you're just shot because you've been just not giving yourself a break and just listening to me for too long, then, for example, you're just not going to have as good a quality study. How many people still need to do the sample test? Okay, this would be a good evening to give yourself like an hour or an hour and a half.